Okay, so today we're going to talk about factoring by grouping again. This time we're going to look at actual quadratic equations, which are what you get when you multiply two binomials or a pair of, groups together that each have two terms. Okay, now the thing that we need, so again, our end result is going to look something like this: x plus 2, x minus 5, or something like that. That's what we're trying to get to. But we're going to be given something like this that has already been multiplied through. So we got to kind of undo it. So to do this by factoring, we need to figure out two things. We need to figure out two numbers, basically. We need to figure out what a and b are. Now, a and b are two numbers that when you take the coefficients of the first and last term and multiply them. So in this case, if I'm looking at this one, so a times b has to equal 1 times 6, which is just 6, right? Then these two numbers also have to, when you add them together, equal the coefficient of the middle term. So first and last multiply, and then we also need to be able to add them together to get 5. Okay, now when we look at this, 1 times 6, add them together, we wouldn't get 6, we would get 7, right? So it can't be 1 and 6, so the two numbers have to be, what else could multiply to get 6? It would be 2 and 3. So a and b would have to be 2 and 3. Add them together, we get 5. Now here's the trick. We're going to rewrite this as x squared plus 2x plus 3x plus 6 or whatever. But the grouping kind of matters. We got to make sure when we put it in there that we combine them in a way that they have the common coefficient, or the common factor, the common factor in a group. Now, x squared probably isn't going to have much except for the x, but the 3 would go into the 6, right? So we'll leave the 3 in the second group, and we'll put 2x in this first group, and then we'll do 3x plus 3x plus 6 in our second group. Okay. And notice I already grouped them just like I did last time, because I'm going to do kind of the same thing where I take out the common factor in each, and then we'll get our binomial, which will look like this when all is said and done. So if I look at this, common factor would be an x, right? So I take out an x, I have x times x plus 2. And then this one, common factor would be a 3. So I take out the 3, so plus 3 times x plus 2. Now I have the same binomial. I'm going to factor that out in front, and I'm going to get x plus 2 being multiplied with x plus 3. And that would be my final answer. Okay, let's try that again. So again, I need two numbers that would multiply the coefficient of the first and the second. So in this case, it would be 1 times 16, which is just 16. Okay, and then they also need to add together to equal 10. Okay, so 1 plus 16 is 17, so that doesn't equal 10. Let's see, 8 times 2 would equal 16. That would equal 10, so that works. So 8 times 2. Okay, so again, I'm going to break this up. But again, I'm going to look for common factors here. And I can already tell that the 8 would go best with the 16, right? So I'm going to move the 8x next to the 16. So when I rewrite it, it would be x squared plus 2x plus 8x. Because again, combine those, we'd get 10x. And then plus 16. Now I'm going to group them in factor. So group, factor. First group, all I have is the x. So I'm going to take out the x. I'll rewrite it. X is x plus 2 plus, and then I'm going to take out the 8. So 8, and it'll be x plus 2. Okay? They have the same binomial there. I'm going to factor that in front. I'm going to be left with x plus 8 here. So I have x plus 2 be multiplied with x plus 8. Okay? Not too tough, right? Looks a lot harder than it actually is. Let's try another one. Let's do one of these down at the bottom here. So, with this one, I have to have two numbers when you take 1 and negative 27. So, 1 times negative 27 has to equal negative 27. Okay? And then they have to add up to be 6. So I need something that equals negative 27 but adds to be 6. So I'm going to have a negative and a positive because that's what happens when you multiply, right? So think about what multiplies and gets 27. So 27, I can only think of one multiple, and it would be 9 and 3, right? So if I do a positive 9 and a negative 3, negative 3 plus 9 would equal a positive 6. Good. So that works. So that's going to be my two x's that I'm going to have here, a negative 3x and a 9x. Now 9 I know goes with negative 27 really well, so I'm going to stick that one next to the negative 27 when I rewrite this. So x squared minus 3x plus 9x minus 27. That's it rewritten. So now I'm going to group them. Okay. First one I can take out the x. Second one I can take out the 9. So hold on, let me rewrite this. X leaves me x minus 3. Take out the 9, and I would have x minus 3. Same binomial. So again, factor out the binomial now, and you're going to have x minus 3 in front multiplying with x plus 9. And that is your answer.